Hello students, welcome to this video lesson. Today we shall be discussing the chapter Interior of the Earth. We shall begin by taking a quick look at the structure of the Earth. You are already familiar with this part of the chapter, but let's revise once again. Take a look at the three main layers of the Earth. The outermost solid part, or the crust. The thickness of the crust varies. It is less under the oceans and most in the areas of the major mountain systems, such as the Himalayas. The mantle lies beyond the crust. It begins from the Moho's discontinuity or the Mohorovicic discontinuity, which is the boundary line between the crust and the mantle. The mantle has a weak upper portion called the asthenosphere. The molten rock materials from the interior of the Earth find their way to the surface from this zone. The core, also referred to as the knife layer, is made up of very heavy material, mostly constituted by nickel and iron. The outer core is in the liquid state, while the inner core is in the solid state. Now that we have taken a quick look at the structure of the Earth, let's discuss the sources of information about the interior of the Earth. Since it has been impossible to reach the center of the Earth and study it, we rely on several estimates, inferences, and a sample of observation and deductions to understand the Earth's interior. We have the direct and the indirect sources to draw our inferences from. The direct sources of information include the study of rock available to us on the surface, the rocks we get from mining the Earth. The Maponeng gold mine and the Tautona gold mine in South Africa are the deepest mines in the world. Volcanic eruptions and the analysis of magma that reaches the surface of the Earth. Projects such as Deep Ocean Drilling Project and Integrated Ocean Drilling Project. Now, what is this ocean drilling or deep sea drilling project? The deep sea drilling and the ocean bed drilling projects include the systematic collection of core samples or data from the deep seabed. It has been over 50 years now that the scientists are studying the seabeds. The Kola Super Deep borehole on the Kola Peninsula of Russia is the deepest penetration of the Earth's solid surface. It has reached down to 12,262 meters below the surface. Deep sea drilling and ocean drilling has made a large variety of information available to us for study. You should look it up in your free time. It is indeed quite interesting. Now, let's see the indirect sources which are available to us for observation. The indirect sources of information are increase in pressure and temperature with depth as analyzed from various mining projects, seismic waves studied through earthquakes, the study of meteorites as they are made up of the same materials as the Earth's interior. Gravitation. This varies from place to place. It is greater near the poles and less at the equator. The gravitation readings vary from expected readings from place to place. This is called gravitation anomaly. This tells us about the mass distribution on the Earth's surface, as mass and gravitational force is directly proportional to mass. Now we shall study seismic waves or earthquakes in detail, as an earthquake is a major natural event that helps us to study the interior of the Earth. All earthquakes are caused in the lithosphere. But how are they caused? The shaking caused during an earthquake is due to the release of energy along a fault or break in the rock of the crust. As the rocks along a fault line are pressed from above, by the overlying rocks. The friction prevents them from moving apart. However, this friction is not able to hold the rocks along a fault line for long. Soon, the rocks slide past one another, releasing energy, causing the shake. A seismograph is used to record the waves reaching the surface. Earthquake waves are basically of two types: body waves and surface waves. Body waves travel through the body of the earth in all directions. These are generated due to the release of energy at the focus center. Surface waves move along the surface of the earth. The body waves interact with the surface rocks and generate the surface waves. These waves are more destructive. They cause displacement of rocks and hence the collapse of structures occur. There are two types of body waves, the P and S waves. The P waves, also called the primary waves, are the first to arrive at the surface as they move faster. The S waves, or secondary waves, arrive at the surface with some time lag. There is another major point of difference between these two waves. The P waves can travel through gaseous, liquid, and solid materials, while the S waves can travel only through solid materials. The S waves helps to study the interior of the earth. The earthquake has a shadow zone. What is this shadow zone? The shadow zone is the area of the earth from a given earthquake that does not receive any direct waves. The shadow zone results from S waves being stopped entirely by the liquid core and P waves being refracted by the liquid core. The angular distance between 105 degrees and 145 degrees from the epicenter was identified as the shadow zone for both the waves. The entire zone beyond 105 degrees does not receive S waves. The shadow zone of S wave is much larger than that of the P waves. We shall stop the first part of our discussion here. See you next in the second part of our video lesson, where we shall discuss more about earthquakes and the interior of the earth.